The Den Hague power generation facility, owned and operated by Aon Benelux, was built in 1900 with coal-fired boilers originally occupying the portion of the building that was involved in this project. These boilers have been replaced with a pair of gas turbine generator sets, each with its own exhaust heat recovery boiler to provide steam for a steam turbine generator set in an adjacent portion of the building. These gas turbines were reaching the end of their useful lives, and Aon desired to replace them with new units that would provide the utility, dependability, and economy of state-of-the-art equipment. ESI undertook the task of fulfilling these desires and proposed a system utilizing a single 100-megawatt generator driven by a pair of GE LM6000 DLE gas turbines and reusing the existing exhaust heat recovery boilers. Let's take a look at how this functionally elegant and cost-effective solution was accomplished. We're looking down the turbine hall with the existing gas turbine generator sets to our left. The owner removed these existing units and all associated auxiliary equipment. The existing generator foundations were demolished, and the existing exhaust ductwork was cut back to the first major interface flange. Installation of new equipment could now begin. First of all, the auxiliary skids and the generator lube oil skid were brought in and placed in their approximate final locations, since these areas would be difficult to access once the turbine and generator enclosures were in place. Also, the new exhaust transition ducts were bolted in position for final installation following engine alignment. Enclosure installation began with Unit 2, the farthest from the building entrance, and started with the far wall sections and the end wall sections. The enclosures were assembled from sections that could be easily transported through the picturesque but narrow streets of the city. Enclosure assembly followed a sequence that would coordinate with installation of the filter house and associated ductwork above. Also, the radial inlet plenum, the gas turbine engine base, and the exhaust collector and its base were installed before the near walls were erected and bolted together. The central enclosure roof section was placed with the engine removal trolley already installed, and the VBV exhaust duct was installed from above. The final roof section was bolted in place, and the common wall that would separate the engine enclosure from the generator enclosure was fitted in place, completing the Unit 2 enclosure. As we move back to view the assembly of the generator enclosure, we can see that the Unit 1 engine enclosure has been built in the same sequence as the Unit 2 enclosure. The two engine enclosures help to frame the opening for the formwork for the new concrete generator foundation. Note the raised pedestals at the ends of the generator foundation that will support the new speed reduction gearboxes. The owner was responsible for the modifications to the existing steel building frame in this area. The generator enclosure walls, like those of the gas turbine enclosures, were assembled from a number of panels that could be easily shipped to the site. The gearboxes were installed next, followed by the overhead roof sections with the beams that will allow future gearbox maintenance. The height of the generator required that the generator enclosure walls be made in two vertical sections, and the upper wall sections were added next, followed by the beam and columns that frame the generator removal opening. The generator roof framing was added, and finally, the generator enclosure roof panels. The generator, with its cooler attached, was too tall to enter the building, so the cooler was removed, brought in, and raised using the existing bridge crane through the existing access opening in the first floor above. The generator was brought in, and the cooler reassembled to it. The complete generator and cooler assembly was then moved into the generator enclosure. The line side and neutral cubicles were installed, and then the framing and wall panels of the generator removal wall were assembled, completing the generator enclosure. The gas turbine enclosure cooling air exhaust fans and ductwork were added to complete the enclosure cooling air system. The engine removal beam and its supporting A-frame were then installed. This one removal beam is used for either engine, but each enclosure has its own A-frame permanently installed. Here we can see how the Unit 1 gas turbine, supported by the engine lift fixture, was moved into its enclosure. Both the Unit 1 and the Unit 2 gas turbines were installed in this manner, and both on the same day. The removal beam was unbolted and taken away, and the engine removal panel and enclosure doors were added. Stairs and access platforms would soon be added to complete the installation. Now let's go up to the first floor level to see what's been happening there. From here, we can see that the filter houses and their support structures have been installed, along with the inlet air, enclosure cooling air, and VBV exhaust silencers and ducts. Also note the new local control room, which has been assembled in place at this level. Now let's take a bird's eye view so that we can see the whole drivetrain. We'll start at the left with the Unit 1 gas turbine. Its flex coupling is driven from the intake, or cold end drive end. The flex coupling transmits power to the Unit 1 speed reduction gearbox. The Unit 1 and Unit 2 gearboxes also incorporate clutch and brake systems that allow either gas turbine to drive the generator individually or together for full power. The 100 megawatt generator is next, followed by the Unit 2 gearbox, the Unit 2 flex coupling, and the Unit 2 gas turbine, driven from its aft or hot end drive end. And that concludes our virtual tour of the Den Haag Repower project construction. Thanks for coming along.